At 20:47 hours on May 26, 1941, Sub-Lieutenant John Moffett sat in the cockpit of his Fairey Swordfish torpedo bomber at 6,000 feet above the Atlantic Ocean, watching the German battleship Bismarck turn through 360 degrees in a continuous circle below. Moffett commanded one aircraft in a strike force of 15 Swordfish launched from HMS Royal 40 minutes earlier. The carrier was operating 120 miles southeast of Bismarck's last known position, steaming at maximum speed to close the range before darkness made further operations impossible. For 31 hours, the Royal Navy had been searching for Bismarck after losing contact following the Denmark Strait battle. The battleship had vanished into the vastness of the Atlantic with her fuel tanks leaking, her crew exhausted, and her orders to reach the safety of Brest, France, where Luftwaffe air cover and German naval forces could protect her. If Bismarck escaped, she would be repaired, refueled, and returned to operations. If she reached Brest, she would threaten every convoy crossing the Atlantic for the next 2 years. Moffett's torpedo weighed 1,610 pounds, carried a 388-pound Torpex warhead, and had a maximum range of 1,500 yards at 40 knots. His aircraft was a biplane with a maximum speed of 138 miles per hour slower than most fighters of 1918. The Swordfish was obsolete fabric-covered, and so slow that modern fighters often overshot when attacking it. But it was stable, it was reliable, and it could carry a torpedo in weather that would ground modern aircraft. Moffett descended through heavy weather at 20:53 hours. Rain lashed his cockpit. Wind buffeted the Swordfish. Visibility was less than 500 yards. At 20:55 hours, he broke through the cloud base at 700 feet and saw Bismarck 2 miles ahead, her anti-aircraft guns firing at other Swordfish already attacking. Moffett pushed the stick forward and descended to 90 feet above the wave tops. His observer in the rear cockpit armed the torpedo. His air gunner reported flak bursts behind them. At 20:55 hours and 30 seconds, Moffett released his torpedo 800 yards from Bismarck's port quarter. The torpedo dropped from its cradle, hit the water stabilized, and began its run toward the battleship. Moffett banked hard right and climbed away at full throttle. Behind him, the torpedo traveled at 40 knots through 6-foot seas. Impact time was 45 seconds. Moffett did not see the hit. He was flying through anti-aircraft fire focused on escaping. But aboard Bismarck, the torpedo struck at 20:56 hours, 13 feet below the waterline, directly beneath the stern adjacent to the steering compartments. The explosion was small compared to the ship's size. A column of water rose along the port quarter. The hull shuddered. Damage control parties reported flooding in the steering gear compartments. Captain Ernst Lindemann, commanding Bismarck from the bridge, ordered helm checks. The rudders did not respond. Engineers reported the steering motors were jammed. The rudders were locked at 12 degrees to port. Bismarck began turning in a circle. In 90 seconds, a single torpedo had transformed the most powerful battleship in the Atlantic into a helpless target. Bismarck would steam in circles for 13 hours while the Royal Navy assembled overwhelming force to destroy her. At 08:47 hours, on May 27th, British battleships would open fire. At 10:36 hours, Bismarck would sink with 104 of her 2,221-man crew. The ship that was designed to dominate the Atlantic, the ship that had destroyed HMS Hood 3 days earlier. The ship that represented Germany's resurgence as a naval power would be lost because a single torpedo hit the one vulnerable point that should never have been exposed. The fatal flaw was not bad luck. It was a design decision made in 1935 by engineers who prioritized offensive capability over defensive resilience. They placed Bismarck's steering gear outside the main armored citadel to save weight and maximize internal space. That decision killed 104 men. Bismarck was laid down at Blohm & Voss shipyard in Hamburg on July 1, 1936, as hull number 509, the lead ship of Germany's first battleship class constructed after the restrictions of the Treaty of Versailles were repudiated. The Anglo-German Naval Agreement of June 18, 1935, allowed Germany to build a navy up to 35% of the Royal Navy's tonnage. For capital ships, this meant Germany could construct battleships totaling approximately 183,000 tons. German naval planners had been preparing for this moment since the early 1930s. Design studies for new battleships began in 1933, conducted in secret to avoid violating Versailles Treaty restrictions. The studies examined various armament schemes, armor distributions, and propulsion systems. The goal was a battleship capable of defeating any French capital ship while maintaining sufficient speed to raid British commerce in the Atlantic. The design that became Bismarck was approved in January 1935. She would displace 41, 637 tons, standard 5,300 tons fully loaded. Her main battery would consist of 8 15-inch SKC-34 guns in 4 twin turrets, 2 forward and 2 aft. Each gun could fire a 1,764-pound armor-piercing shell to a maximum range of 36,520 yards. Rate of fire was 2.5 rounds per minute per gun. The turrets were designated Anton and Bruno forward, Caesar and Dora aft. Secondary armament consisted of 12 5.9-inch SK-28 guns in 6 twin turrets, 3 on each beam. These were dual-purpose weapons effective against surface targets and aircraft. Anti-aircraft defense included 16 4.1-inch guns, 16 37mm guns, and 12 20mm guns. This was the heaviest anti-aircraft battery fitted to any battleship in 1941. Propulsion was conventional. 12 Wagner high-pressure boilers fed 3 steam turbines driving 3 screws. The turbines generated 150-170 shaft horsepower, producing a maximum speed of 30.8 knots. Range was 8,525 nautical miles at 19 knots. Fuel capacity was 7,400 tons of oil. The specifications were impressive but not exceptional. British King George V class battleships mounted 10 14-inch guns and displaced 42 237 tons. American North Carolina class battleships mounted 9 16-inch guns and displaced 44 800 tons. Bismarck was competitive but not superior to contemporary battleships. What made Bismarck notable was her armor scheme. German armor philosophy differed fundamentally from British and American approaches. British and American battleships used the all-or-nothing armor scheme developed during World War I. Heavy armor protected vital spaces, the magazine's machinery, fire control. Everything else was left unarmored. The logic was that damage to non-vital spaces was acceptable. Protecting critical systems allowed the ship to remain combat effective even after absorbing multiple hits. German designers rejected this approach. They believed distributed armor was superior. Bismarck's armor protection extended over 70% of her length compared to approximately 50% for American battleships. Her belt armor was 12.6 inches thick amidships, tapering to 5.5 inches at the bow and stern. Her main armored deck was 3.9 inches thick over the magazines, 4.7 inches over the machinery spaces. Turret faces were 14.2 inches thick. The conning tower was 13.8 inches thick. The armor was comprehensive, well-designed, and exceeded treaty limitations. Britain and America had agreed to limit battleship displacement to 35,000 tons standard under the Washington and London naval treaties. Bismarck's declared displacement was 35,000 tons. Her actual standard displacement was 41,637 tons, 19% over the limit. Germany had no intention of honoring treaty restrictions. The extra displacement was used primarily for armor and subdivision. Bismarck had 22 watertight compartments along her length divided by transverse bulkheads. Her anti-torpedo protection consisted of a series of void spaces, fuel tanks, and compartments designed to absorb explosion energy and prevent flooding from reaching vital spaces. The system was tested extensively using explosive charges against sections of hull. The tests showed Bismarck could survive multiple torpedo hits amidships without losing buoyancy or propulsion. But the tests did not examine the stern. The steering gear compartments were located at the extreme stern, 50 feet aft of the main armored citadel. The reasoning for this placement was engineering efficiency. Steering gear needed to be close to the rudders to minimize mechanical complexity. Placing the steering gear inside the armored citadel would require extending the armor belt 50 feet aft, adding approximately 1,000 tons of weight. The designers chose to save that weight. The steering gear itself consisted of 3 separate systems, 2 main steering motors, each capable of turning the rudders independently, 1 emergency hand steering system operable from the steering compartment aft. Rudder angle was controlled by hydraulic systems linking the bridge to the steering motors. The rudders themselves were twin rudders, each 76 square feet in area, mounted on separate stocks immediately aft of the three propeller shafts. The compartment containing the steering motors was protected by 2.4-inch armor on the sides and 1.2-inch armor overhead. This was sufficient to defeat destroyer gunfire, but not battleship shells or aerial torpedoes. The design assumed that enemy weapons would not reach the steering compartments because the extreme stern was a small target, difficult to hit, and unlikely to be targeted deliberately. This assumption was reasonable for surface combat. In a gun battle, opposing battleships would target each other's turrets, bridges, and waterline amidships where magazines and machinery were located. The stern was a low-priority target. But the assumption ignored aerial torpedoes. A torpedo striking the stern would explode directly adjacent to the steering gear. The light armor would provide minimal protection. If the steering motors were damaged or the rudder stocks jammed, the ship would lose steering control. British battleships had similar vulnerabilities. HMS Prince of Wales, which fought alongside Hood at Denmark Strait, had her steering gear located outside the main armor belt. So did HMS King George V. American battleships also placed bow steering gear aft of the main armor. The vulnerability was universal. Every navy made the same weight-saving compromise. The difference was that most navies recognized the risk and implemented redundancy. American battleships had 4 independent steering systems with multiple control stations. Damage to one system would not disable the ship. British battleships had 3 steering systems with emergency hand steering stations accessible from multiple locations. German engineers provided Bismarck with 3 steering systems, but all 3 systems controlled the same rudder stocks. If the rudder stocks jammed, all 3 systems became useless. There was no way to disconnect the rudders and steer using propellers alone. This was the fatal flaw. Bismarck could survive torpedo hits amidships. She could survive shell damage to her superstructure. She could survive flooding fire and power loss. But a single torpedo hit to the stern, if it jammed the rudders, would render her uncontrollable. And once uncontrollable, she would be unable to escape, unable to fight effectively, and unable to avoid being overwhelmed by superior force. The vulnerability was identified during design reviews in 1935. Naval architects noted that steering gear placement outside the armor belt created risk. They recommended either extending the armor belt to protect the steering compartments or providing a mechanism to disconnect the rudders if they jammed. Both recommendations were rejected. Extending the armor would exceed weight limits. Providing a rudder disconnect mechanism was deemed unnecessary because the probability of a stern hit was considered low. The decision was approved by Admiral Erich Raeder, Commander-in-Chief of the Kriegsmarine, in March 1936. Construction proceeded. Bismarck was launched on February 14, 1939. She was commissioned on August 24, 1940. She conducted sea trials in the Baltic through late 1940 and early 1941, testing her machinery, weapons, and handling characteristics. The trials revealed no problems with the steering gear. The system functioned perfectly under all tested conditions. On May 18, 1941, Bismarck departed Gotenhafen in occupied Poland for Operation Rheinübung, her first and only combat operation. Her mission was to break out into the Atlantic and attack British convoys, bringing food, fuel, and munitions from North America to Britain. Accompanying Bismarck was the heavy cruiser Prinz Eugen. The 2 ships would operate together, using Bismarck's heavy armament to destroy convoy escorts, while Prinz Eugen attacked the merchant vessels. The operation was approved by Admiral Raeder, despite warnings from Admiral Günther Lütjens, commanding the task force. Lütjens argued that Bismarck should wait for the battleship Tirpitz to complete working up. 2 battleships operating together would be far more effective than 1 battleship and 1 cruiser. Raeder overruled him. Tirpitz would not be ready for months. British convoys were vulnerable now. Bismarck had to sail immediately. Lütjens accepted the order, but recognized the risks. Bismarck and Prinz Eugen would be outnumbered by the Royal Navy's home fleet. Success depended on avoiding detection until reaching the convoy routes. Once among the convoys, Bismarck could inflict enormous damage before the Royal Navy could concentrate forces to engage her. But if she was detected during the breakout, if British forces intercepted her before she reached the open Atlantic, the operation would fail. The breakout route passed through the Denmark Strait between Iceland and Greenland, then south into the Atlantic shipping lanes. British intelligence detected Bismarck's departure from Gotenhafen on May 19 through ultra-decrypts of German naval communications. The Admiralty ordered the home fleet to intercept. The battlecruiser Hood and battleship Prince of Wales were dispatched to the Denmark Strait under Vice Admiral Lancelot Holland. Additional forces were positioned to cover other possible breakout routes. On May 24 at 0600 hours, Holland intercepted Bismarck and Prince Eugen in the Denmark Strait. The engagement lasted 16 minutes. Hood exploded and sank at 0601 hours, destroyed by a shell from Bismarck that penetrated her deck armor and detonated in her after magazines. Prince of Wales was hit 7 times and withdrew her main battery, malfunctioning her bridge, wrecked her captain and several officers wounded. Bismarck had won the tactical engagement decisively, but she had been hit 3 times by Prince of Wales. One shell struck below the waterline forward, rupturing fuel tanks and causing flooding. The flooding reduced Bismarck's speed from 30 knots to 28 knots. More critically, the ruptured fuel tanks were forward of the collision bulkhead. The fuel in those tanks was inaccessible. Bismarck lost approximately 1,000 tons of usable fuel, reducing her range by 2,000 nautical miles. Admiral Lutyens assessed the situation. Bismarck was damaged, leaking fuel, and had demonstrated her position to the Royal Navy. Continuing the operation was impossible. He ordered Bismarck to proceed to Brest for repairs. Prince Eugen would separate and operate independently. At 1814 hours on May 24, Prince Eugen detached and headed south. Bismarck continued southeast toward France at 20 knots to conserve fuel. British forces pursued. The battleships HMS King George V and HMS Rodney, the battlecruiser HMS Renown, the carrier HMS Ark Royal, and numerous cruisers and destroyers converged on Bismarck's position. But Lutyens executed a deception maneuver. At 0306 hours on May 25, Bismarck reversed course and steamed directly at her pursuers, passing within 10 miles of them in darkness. The British ships lost radar contact and spent the next 31 hours searching in the wrong direction. Bismarck was free. At 0900 hours on May 25, she was 250 miles southeast of her last known position, steaming toward Brest at 20 knots. British forces were searching northwest, believing she was attempting to return to Germany through the Denmark Strait. If Bismarck maintained course and speed, she would reach Brest on May 27. German U-boats and Luftwaffe aircraft would be waiting to escort her the final 200 miles. She would be safe. But at 10:30 hours on May 26, a Catalina flying boat from RAF Coastal Command located Bismarck 690 miles west of Brest. The sighting was transmitted immediately. The Admiralty calculated intercept courses for all available forces. HMS King George V was 130 miles north of Bismarck but could not catch her before she reached air cover. HMS Rodney was 100 miles northwest, also too far. The only force capable of slowing Bismarck was Force H, commanded by Admiral James Somerville, approaching from Gibraltar. Force H consisted of the battlecruiser HMS Renown, the carrier HMS Ark Royal, the cruiser HMS Sheffield, and 6 destroyers. Ark Royal launched a strike of 15 Swordfish at 1450 hours. The strike mistakenly attacked Sheffield, which was shadowing Bismarck. The torpedoes were equipped with magnetic exploders that detonated prematurely in the rough seas. Sheffield evaded all torpedoes, but the strike revealed serious problems with the magnetic exploders. Ark Royal launched a second strike at 1910 hours. 15 Swordfish armed with torpedoes fitted with contact exploders instead of magnetic exploders. The strike was coordinated by Lieutenant Commander Tim Coode. Each aircraft would attack independently from different directions to saturate Bismarck's defenses. Weather was deteriorating. Visibility was less than 1,000 yards. Cloud base was 600 feet. Seas were 6 to 8 feet. The Swordfish crews called it perfect torpedo attack weather. The battleship would have difficulty tracking targets, while the slow, low-flying Swordfish would be difficult to hit. The strike located Bismarck at 2047 hours. Individual virtual aircraft began attacking from multiple directions. Bismarck maneuvered violently, turning to present her stern to incoming torpedoes, then reversing to meet attacks from different angles. Her anti-aircraft batteries fired continuously, the sky filled with flak bursts and tracer rounds, but the Swordfish were small, slow targets in poor visibility. Most aircraft attacked without being hit. Sub-Lieutenant John Moffett approached from the port quarter at 20:55 hours. He descended to 90 feet and aimed for Bismarck's stern. His observer, Sub-Lieutenant John Miller, armed the torpedo at 1,000 yards range. Moffett steadied his approach. The aircraft was buffeted by flak bursts. Water spouts from near misses erupted around him. At 800 yards, he released the torpedo. The torpedo entered the water correctly stabilized and began its run. Bismarck was turning to starboard, presenting her port side. The torpedo tracked on a slight converging angle. Impact point would be the port quarter below the waterline adjacent to the steering compartments. The torpedo struck at 20:56 hours, 13 feet below the waterline, 50 feet forward of the stern. The warhead contained 388 pounds of Torpex, an explosive mixture 50% more powerful than TNT. The explosion occurred immediately adjacent to the steering gear compartment. The blast wave traveled through the water and hull plating. The steering compartment's 2.4-inch side armor was insufficient to stop the shockwave. The explosion ruptured internal bulkheads, flooded the compartment, and jammed both rudder stocks. The rudders were locked at 12 degrees to port. The port rudder stock was bent. The starboard rudder stock was jammed in its bearing. Neither could be moved. Aboard Bismarck, damage control parties responded immediately. Chief Engineer Korvettenkapitan Walter Lehmann led a team aft to assess the damage. They found the steering compartment flooded to a depth of 6 feet. Both steering motors were submerged and inoperative. The rudders were jammed and could not be moved by hand. Emergency hand steering was attempted but failed. The rudder stocks were mechanically locked. At 21:15 hours, Captain Lindemann reported to Admiral Lütjens that steering control was lost. Bismarck was turning continuously to port in a circle approximately 1,000 yards in diameter. Speed was reduced to 10 knots to minimize the turning effect, but the ship could not be steered straight. Lehmann proposed 3 options. First, send divers over the side to examine the rudders and attempt repairs. This was attempted at 2200 hours. A diver went over the stern in heavy seas and examined the port rudder. He reported the rudder stock was bent and the rudder blade was jammed against the hull. Repair was impossible without dry dock facilities. Second, disconnect the rudders and steer using propellers alone. This required cutting through the rudder stocks with torches underwater. The rudder stocks were 14 inches in diameter, made of hardened steel. Cutting them would take hours and required calm seas. The current sea state made this impossible. Third, weld the rudders amidships in a neutral position. This also required underwater cutting and welding in heavy seas. Lehmann estimated it would take 12 hours minimum, possibly 24 hours, assuming weather improved. Lütjens assessed the situation. Bismarck was 400 miles from Brest, circling at 10 knots, unable to steer. British battleships were converging from the north and would arrive by dawn. Air attacks would continue through the night. U-boats had been summoned but were 12 hours away. Luftwaffe aircraft from France could provide air cover at dawn, but only if Bismarck was within 200 miles of the coast. At 10 knots, steaming in circles, she would never reach that point. Lütjens radioed Berlin at 2140 hours. Ship unmaneuverable. We will fight to the last shell. Long live the Führer. The message was intercepted and decrypted by British intelligence within an hour. The Admiralty knew Bismarck was crippled. At 2300 hours, Admiral John Tovey, commanding the home fleet from HMS King George V, calculated intercept times. King George V and Rodney would reach Bismarck at approximately 0800 hours on May 27th. Tovey ordered maximum speed overnight. The battleships would engage at dawn. Through the night of May 26-27, British destroyers attacked Bismarck with torpedoes. The attacks achieved no additional hits but prevented German damage control parties from working on the rudders. Every time divers went over the side, torpedo tracks forced them back aboard. By 200 hours on May 27th, German engineers abandoned repair attempts. The rudders could not be fixed at sea. Lütjens ordered Bismarck to attempt steering using propellers. By varying power to the 3 screws, the ship could be induced to turn slightly. The technique was partially successful. Bismarck managed to steady on a heading of northeast approximately 310 degrees by running the port outer shaft at 200 revolutions, the starboard outer shaft at 150 revolutions, and the center shaft at 180 revolutions. This unbalanced thrust counteracted the rudder's tendency to turn the ship left. But the solution was temporary and inadequate. The ship could not hold course in changing seas. The propeller shafts were not designed for sustained unbalanced loading. Bearings began overheating. Speed was limited to 7 knots, and the course was wrong. Bismarck was heading northeast away from France back toward the British fleet. Lutyens accepted the inevitable. Bismarck would fight where she was. At 600 hours on May 27th, he ordered the crew to prepare for surface action. Non-essential personnel were moved below the armored deck. Damage control parties were stationed throughout the ship. Magazines were fully stocked. Guns were loaded. At 8:43 hours, HMS Rodney spotted Bismarck 23,000 yards northwest. At 847 hours, Rodney opened fire with her 9 16-inch guns. HMS King George V opened fire at 8:48 hours with her 10 14-inch guns. Bismarck returned fire at 8:50 hours. Her fifth salvo straddled Rodney. Her gunnery was accurate despite her steering problems, but Bismarck was nearly stationary, unable to maneuver, presenting a stable target. British shells began hitting within 10 minutes. At 09:02 hours, a 16-inch shell from Rodney struck Bismarck's forward superstructure, destroying the forward fire control station and killing most of the gunnery officers. Bismarck's main battery fire became sporadic and inaccurate. At 09:13 hours, another 16-inch shell hit Anton turret, jamming it in train. At 09:27 hours, Bruno turret was hit and knocked out. By 9:31 hours, both forward turrets were out of action. Bismarck's after turrets continued firing, but the range had closed to 12,000 yards. British battleships were firing rapidly, hitting repeatedly. By 09:40 hours, Caesar turret was destroyed. At 1002 hours, Dora turret, the last operational main battery turret, ceased firing. Bismarck's main armament was completely silent, but she remained afloat. Her armor had protected her magazines and machinery spaces. British shells could not penetrate the main belt armor at the ranges being fought. Bismarck was burning battered, her superstructure destroyed, but her hull remained intact. Admiral Tovey ordered cruisers to close and finish Bismarck with torpedoes. HMS Dorsetshire fired torpedoes from 3,000 yards. 2 hit Bismarck's starboard side. Dorsetshire maneuvered to port and fired a third torpedo into Bismarck's port side. At 10:36 hours, Bismarck rolled to port and sank. She went down in position, 48 to Degand, 16 to G12. View approximately 300 miles west of Brest in water 617 feet deep. Of her crew of 221 men, 114 survived. They were rescued by HMS Dorsetshire and the destroyer HMS Maori before U-boats arrived and forced the British ships to withdraw. Approximately 300 German sailors were left in the water. Most died from exposure. One additional survivor was rescued by a German weather ship 3 days later. The final count was 115 survivors, 106 dead. The wreck of Bismarck was located on June 8, 1989 by Robert Ballard using deep-water sonar. The wreck lies upright on the seafloor in 17 feet of water. The hull is largely intact. The superstructure is heavily damaged from shell fire. The turrets have fallen off during the descent or shortly after sinking. Video footage from remotely operated vehicles showed extensive shell damage to the upper works, but relatively little damage to the armored belt. The stern section shows the torpedo damage that disabled the steering gear. Examination of the wreck confirmed the sequence of Bismarck's loss. The ship was not sunk by British gunfire. The armor belt remained intact. Magazines did not explode. Machinery spaces were not flooded by shell hits. Bismarck was scuttled by her crew. Survivors testified that scuttling charges were detonated in multiple compartments at approximately 10:30 hours, flooding the ship to prevent her capture. The British torpedoes from Dorsetshire contributed to the flooding but were not the primary cause of sinking. The technical analysis of the steering gear damage revealed that Moffat's torpedo struck approximately 15 feet forward of the rudder stocks. The explosion created a shockwave that traveled through the water, through the hull plating, and into the steering compartment. The blast ruptured bulkheads, flooded the compartment, and jammed the rudder stocks. The port rudder stock was bent at an angle of approximately 12 degrees. The starboard rudder stock was jammed in its bearing due to distortion of the bearing housing. The damage was catastrophic because there was no redundancy. Both rudders were controlled by the same mechanism. Damage to that mechanism disabled both rudders simultaneously. There was no way to disconnect the rudders and steer using propellers alone, at least not quickly enough to matter. The design that was supposed to save 1,000 tons of armor weight cost 106 lives. Comparisons with contemporary battleships reveal how unusual Bismarck's vulnerability was. U.S. North Carolina, when commissioned in April 1941, had 4 independent steering systems. 2 main steering systems controlled separate rudder stocks. 2 emergency systems could disconnect the rudders and steer using propellers. Damage to one system would not disable the ship. HMS King George V had 3 steering systems with multiple control stations. Emergency hand steering could be operated from 3 different locations. If one steering station was destroyed, others could take over. Bismarck had 3 steering systems, but all 3 controlled the same rudder stocks from the same location. The systems provided redundancy against electrical or hydraulic failure. They provided no redundancy against physical damage to the rudder stocks themselves. Once the rudder stocks jammed, all 3 systems became useless. The vulnerability was known. During Bismarck's sea trials in early 1941, engineers recommended installing a mechanism to disconnect the rudders in case of damage. The mechanism would allow the rudders to be locked amidships manually, then released from their control linkages. The ship could then be steered using propeller thrust. The recommendation was forwarded to Admiral Raeder. He rejected it. Installing the mechanism would require cutting through structural bulkheads, weakening the stern structure. The risk of structural damage was considered greater than the risk of rudder damage. The modification was not made. Bismarck sailed for Operation Rheinübung, with her steering gear in the same configuration as designed in 1935. 9 days later, she was on the bottom of the Atlantic. The lesson of Bismarck's loss is that single points of failure are fatal in combat. Bismarck was designed to survive multiple shell hits, multiple torpedo hits, flooding fire and power loss. But she could not survive damage to her steering gear because the steering gear had no redundancy. One torpedo hit disabled both rudders simultaneously. Once disabled, the ship could not maneuver, could not escape, and could not avoid being overwhelmed by superior force. The design flaw was not that the steering gear was placed outside the armor belt. Every battleship made similar compromises. The flaw was that German engineers provided no backup system. They assumed steering gear damage was unlikely and therefore did not require redundancy. The assumption was wrong. The probability of a stern hit by torpedo was low, but not zero. And when that low probability event occurred, it was fatal. The decision to save 1,000 tons of armor weight by not extending the armor belt to protect the steering compartments was defensible. Weight was limited by treaty restrictions, and armor had to be prioritized for magazines and machinery spaces. But the decision not to provide a rudder disconnect mechanism was indefensible. That mechanism would have weighed less than 5 tons, required minimal installation work, and would have allowed Bismarck to steer using propellers after rudder damage. The cost was trivial. The benefit was survival. Admiral Raeder's rejection of the modification represented a failure of engineering judgment. He prioritized structural integrity over operational resilience. He assumed combat damage would be manageable through existing systems. He was wrong. One torpedo proved him wrong. At 20:56 hours on May 26, 1941, Sub-Lieutenant John Moffat's torpedo struck Bismarck's steering compartment. The explosion jammed both rudders. The ship turned in circles for 13 hours, then died under the guns of 2 battleships she could have escaped if she could have steered straight. Bismarck was not a bad design. Her armor was excellent. Her subdivision was comprehensive. Her guns were effective. But she had a single fatal vulnerability that should never have existed. The steering gear outside the armor belt was acceptable. The lack of a rudder disconnect mechanism was not. That single design decision made in 1935 to save installation work and preserve stern structural integrity killed 106 men in 1941. The fatal flaw of Germany's last great battleship was not what was built, it was what was not built. The 5-ton mechanism that would have saved her was rejected to avoid cutting through 2 bulkheads. 2 sick men died because someone decided that cutting through bulkheads was too much trouble.